Hello friends, let's welcome back to the next example. So design of a Turing machine to convert any unary number into a binary conversion, unary to binary conversion. So just to look at this example, the procedure to convert your decimal to binary as it is sequentially. So 5, we take 2, the remainder is 1, so we'll write it. So 2 divided by 2, we'll take the remainder 0 and 2, 1 divided by 2, then remainder is 0, but your division is 1. And we read this in a reverse order. That is important. We write this in a reverse order. So this reverse is 101. For this time, it's like a palindrome, it looks like. But whatever result you remainder you get, you read from bottom to top right now. So in a reverse order, we read this. So 5 is converted back to its binary. Now note that number, if see for this conversion we need to remember what is the remainder. So either the remainder would be 1 if the number is odd, okay, and if the number is even, we'll get the remainder 0. So either of this would be true. Either 0 would be the remainder, either 1 would be the remainder. So whenever number is even, so we'll write remainder as 0. If number is odd, we'll write remainder as 1. So putting the result onto the tape of the Turing machine will replace a 0. So 0 remainder is represented as A, and 1 is represented as B. Okay. Now consider if the input is x is 2, it has to be converted back to binary as 1 0, but on tape it should look like BA. So 0 is for A and 1 is represented by B. So it should give me the result as BA after processing this 2. Now, as I said, so what are the reminders? So reminders, either it would be 0 or 1, and the input is given in terms of unary format. Unary format means the 5 we need to process. So on tape we need to have 5 ones, single ones. So we cannot process directly this decimal number system. So this has to be converted back to unary. Okay. So this is what the consideration over is. Unary format has to be converted back to binary. So all such numbers are represented by those many number of ones on the input tape. So if I have 5 ones will be available to be processed on input tape. And as I said, the remainder either would be 0 or 1. So in this design procedure, this is the example of the state chart diagram which Turing machine moves, which are capable enough to give me the results. If I provide the unary format of any binary, then it convert back to its binary number system. So if you receive decimal in terms of unary, then it can convert this back to binary number system. So in this idea is very simple. When you start over this, so the arrow coming from nowhere, it is represented, R0 stands for remainder 0. So this is for our consideration, we have written this R0, but the state is represented as Q0, and in this R1 means remainder 1. So this is represented by Q1. Now let's check how the process goes. So if we try to process the simple format, so we can check back for all the number system which exist, okay, thereafter after this explanation. So how to design this? So the designs is simple. So what my initial state of the machine is, I am in Q0 state. This is blank cell on the left, blank cell always available on the right, which has not been shown here. So 2 1, so I'm trying to convert the number 2, which is represented in a unary format with respect to 2 ones. Okay, and the answer which I am supposed to get is BA, which stands for 1 0, which is the binary transformation of 2. Okay, now let's take a single move at a time and check how the process goes. So from Q0 if I'm reading 1, okay, so when I read 1, what would be the reminder? It should be 1 itself. Okay, so this initial step, when you try to read on the input 1, it has to be replaced by a particular character. In this format, we'll represent this by X. You can take any valid alphabet, but for our consideration, we'll replace the first one. Why to replace? Because the machine needs to remember how many ones I have processed still this time. So it changing the one available on tap with a particular character. Okay, so 1 will be replaced by X and the machine head moves towards its right. So the same thing we did. So from Q0, I'll switch back to Q1, switch Q0 to Q, switch back to Q1 by replacing this 1 by X and moving towards right. So now I'm in Q1 and underneath character is 1. Okay, now what the system does is, see, this is a procedure. The first one will be crossed out, the second will retain is as it is, third one will be cross, and the fourth one will be crossed out. Okay, crossed out means how we represent. So one alternative ones we are crossing. Now in this case I have only 2 ones, so 1 is crossed, so I should retain this 1. Okay, so this is the logic, simple logic which we have. So from Q1, if I the next is 1, so once we crossed out a single 1, the second even 1 should be retained this as it is. So this is means changing from even to odd to even. I hope you understood what the logic says. So from Q1, so what the next one is retained. So from Q1, if you receive the next one, this one will be retained, is replaced as it is 1 and move towards right and change from the state from Q1 to Q0. This is what has been done here. So from Q1 state, I'll go to Q0 state by replacing this 1 by 1 and move towards right. Now it is important when you reach to the rightmost null. What I'm saying, when you reach to the rightmost null, either you are taking the exit from this state or this state. It matters a lot. So this state, when you exit, it's a reminder is 0. The output should be A. When you take the exit from here, see, the output should be B. So this is what has been done. So right now, what is the condition? Being in Q0, I'll reach to the rightmost null. Okay, so this is being in Q0. If I'm receiving null, see, it should be replaced as it is and move towards left. Okay, so this is what we have done here. So Q0, we replace this null by null and move towards left. And what would be the state? I'm switching from Q0 to Q4. So from Q0, we'll reach back to Q4. This null will be replaced as it is. We come back to left. Now the point is, I need to write the answer in and that, if you consider, it has to be read in a reverse order. So write it in a reverse order inside a tab, on the tab itself. So what the terminology is, when we try to exit from this even state, I'll remember what to be written. So A should be written on tab, but where? It should be written on the leftmost null which is available. Okay, so for that time, so so machine remembers that I have taken an exit from this, and the machine looks for, it goes towards the left, being in Q4. So for all, it remains into the state Q4 unless and until it reach to the leftmost null. So within traveling from left to, so from right to left, what all symbols it will be seen, say it will see, it will replace it as it is and move towards left unless and until it receives the first null. So this is what it has been, it is doing from Q4, where we were. So from this is where we, so this 1 is written as it is, we move towards left, we'll keep the Q4 as it is. Being in Q4, X will be retained this as it is and will reach to this null. So once you reach to the null left hand side, leftmost null, it indicates that we are went across our input. Okay, we crossed our input and we come back to a empty cell on the left where I need to output my first reminder. So from this, being in Q4, if you're reading null, when you reach to the leftmost null, the machine tries to remember writing the answer by replacing null by A. What A stands for, as we have looked at, A is nothing but what your reminder is. So reminder is 0. We took the exit from this end, so I need to write A on tap. So this is what the machine is following. So being in this state, once you read the null, this will be replaced by A, and again this machine will take its move towards right to check whether any of the ones are left still on tap. So what is doing, you are right now here where this null is replaced by, sorry, see, this null is replaced by the answer A. Okay, and we move from Q4 to Q3. Now what we are trying to go across is, the machine is going across its right to see either any of the ones are left on tape to be counted. Okay, now for time being, it retains the state unless and until the first one comes on the input. Okay, so it either it would see from going from left to right, either it would see X, it replaced by X, go towards right. If whatever answer we stored, either it would be A or B, it replaces the A by A and move towards right, or B by B, it move towards right. See, this is being in Q3. See, being in Q3, if X is available, X would be retained this as it is and move towards right. So being in Q3, X would be replaced and move towards right. When we see the first one, whatever ones are left from this end, we'll replace this one by X and we move towards an odd end. Means now on the next input, see, we have read the single one. So single one, if you take a mod 2, the answer would be, reminder would be 1. So instead of connecting this to even, I have connected this to odd because I have read the first odd number 1. Understood what I'm saying? So this one would be cross checked. Okay, and we move towards right. Okay, so where we were, we reached to this Q1, and now the time has come that, so we'll now the condition is, being in Q1, I'm reading null. So all the input we have exhausted again and we'll reach to the rightmost null now. Okay, now being in Q1, I need to take the exit from this odd reminder state. I'm taking the exit by switching back from Q1 to Q2 by reading null by null and moving towards left again. Okay, so this is the state. So from Q3, sorry, from Q1, if you are reading null, so I need to switch the state from Q1 to Q2 and go towards left. So I'm scanning this X now. Okay, now once you take the exit, my reminder should be stored on tap. Okay, now this is the second second part of this, when we take the exit from this odd one. Okay, now again what I'm trying to see, I wanted to go across all over to the left and find the null over here. Why null? Because this is where I need to write my second reminder. So while going across this, what you can see, I can see X, I can see A, the previously stored, either if ones would be there, one. From going from right to left again, see, it retains the state Q2. For every X, it will retain this X as it is, move towards left. 1, if you encounter 1, it is replaced as it is, move towards left. A, if you go across, it will retain this A as it is, go towards left. B, if it is, it retains that B, right, keep it as it is and go towards left, unless it find out the leftmost null where I need to write the blank symbol. So this is what has been followed by your Turing machine. Being in Q2, if X is there, X is being in Q2, if X is there, X is preserved as it is, move towards left. Being in Q2, if X is there, X is preserved as it is, move towards left. This is the previous reminder which we have written over the tape. So being in Q2, if A receives, the same strategy we apply. The result, previous result, we keep it as it is, move towards left, unless and until we reach to the leftmost null. Okay, now what the time being is, so being in Q2, if the leftmost null receives, where I need to write the answer. So this being in Q2, this null will be replaced by the reminder B. Why B? Because B is reminder 1. We took the exit from this end. So while going across, this reminder should be stored on the leftmost blank cell. So this blank cell will be replaced by B, the reminder. And again, the machine will move towards right to check whether any of this particular ones are left. So I'm moving from Q2 to Q3, Q2 to Q3 while replacing null by B, the answer, and then moving towards right. Okay. Now, unless and until I see the first one, I won't change the state from Q3 to Q1. For all X, A, B, it is written as it is and move towards right. So this is what has been done. Being in Q3, if you read A, it is written as it is, move towards right. Being in Q3, if X is there, write it as it is, move towards right. Q3, if you're reading X, so right, move towards right. And by default, if you come across the rightmost null, means there are no more ones are left. The input is totally exhausted. And being in Q3, if you are reading null, so what the Turing machine is recognizing, see, this null would be replaced by null, and we are accepting the halting statements. By the time once your input is exhausted, so we take the moves from Q3, X is replaced by X, we move towards right. Q3, X is replaced by X, we move towards right. Now the condition is being in Q3, there are no more ones are left. All the 2 ones we have already processed. So being in Q3, if null receives, so I'll switch back from Q3 to HA. So this is what I need to shift it from Q3. If the null receives, this null should be replaced by null and move towards right. So this is an right end where the machine takes a halt. Okay, halt means by the time when the machine takes halt and the input get exhausted, this is where the machine has secured its answer BA. What BA is? So BA is nothing but the answer which is expected in terms of binary after processing this 2. Understood what I'm saying? So this one, for every input, you try to look for the processing of this. Okay, and you will get back. And if you could securely come back to this HA state, the string is accepted and the answer would be available by the time on the Turing machine tab. Are you getting me what I'm saying? But what the logic says, so how did we build up this? So we built up this Turing machine moves based on the logic. Logic is saying that how to convert the decimal number system into binary. Okay, and in this we encounter that every input has to be provided in terms of unary. This is why the problem is represented as unary to binary conversion, not decimal to binary. So if you have 5, the machine needs all the inputs in terms of those number of ones on the tape. Okay, now what is next is how do you reminder? So reminder either would be 0 or 1. So for 0, the answer would be A, and if answer is reminder is 1, the answer would be B. And we read this in a reverse orders. That's why the answers are written from by moving from left to right to its blank cell. So I'm writing it in a reverse order. So when you stop, I can read the answer as from left to right. The answer is rightly available on tape. I hope you understand what I'm saying. And this is how the machine takes its moves. But remember, while crossing across this number of ones, the first one will be whatever ones you have on the input, the first one we will cross, second will be left it as it is, the third will be cross, fourth will be left it as it is. This is what the circular motion of your Turing machine moves. So for first one we cross, we move to the next. For the next one we'll retain as it is. If the third one comes, we'll cross it again, and if for the fourth one we keep it as it is and go towards the change of the state. One is represented 0 reminder and this represents 1 reminder. When you take an exit from this, the answer would be A. I need to write it on tab. If you exit from this route, the answer would be B. It should be written back on tab the way we have seen. I hope you understand. This is really simple. You take any random input and try to observe this on this Turing machine moves. I hope you understand how unary and binary conversion works. Thank you. Thanks a lot.